Hello my dear students, once again welcome back to our online education platform for the integrated classes, the VAVA classes. तो addition of vectors रो ए पार्ट रे आमे डिवीजन फार्मूला विषय डिस्कशन करिबा. जेमति आमे लाइन सेगमेंट रो दुईटा पॉइंट रे गोटे रेशियो डिवाइड करथिला डिवीजन फार्मूला कोऑर्डिनेट वेक्टर पई कि सिमिलरली वेक्टर रे डिवीजन फार्मूला पई कि आमे फार्मूला डिस्कस माने डिराइव करिबा. Let A and B be the position vector of the point A and B respectively. This is A, this is B, and position vector of A is A, position vector of B is B. The position vector of the point P, which divide AB in the ratio m is to n, then internally is, if the point P divide AB in the ratio m is to n internally, then the point P is mb plus na by m plus n, where m plus n not equal to 0. Okay. This point divide AB internally in the ratio m is to n, so it is mb. The coordinate of this point P is mb plus na by m plus n. Okay. So P is mb plus na by m plus n. Now let A B be the position vector of the points A B respectively. Here A is point, B is point. Here A vector is the position vector of A, B vector is the position vector of the point B. The position vector of the point P, which divide AB externally in the ratio m is to n, is mb minus na by m minus n. Okay, where P is the point outside of the AB. That's why it divide in the ratio m is to n externally. The ratio in which xi cap plus yj cap plus zk cap divides the line segment joining x1 i cap plus y1 j cap plus z1 k cap and x2 i cap plus y2 j cap plus z2 k cap is x minus x1 is to x2 minus x, or y minus y1 is to y2 minus y, or z minus z1 is to z2 minus z. If AB are the position vector of the points A, B respectively, okay, if AB is the position vector of the point A and B respectively, then the position vector of the midpoint of AB is A plus B by 2. So point P is A plus B by 2. The median of triangle are concurrent. That we know in coordinate geometry and also in vector algebra. The point of concurrence divide each median in the ratio 2 is to 1. Okay, here ABC is a triangle, AD, VFC are three median, they are intersect at point G, so they are concurrent, and this point divide the median in the ratio 2 is to 1, that is AG by GD is 2 by 1. If ABC are the position vector of the vertices of a triangle ABC, the position vector of its centroid is A plus B plus C by 3. Tetrahedron. What is tetrahedron? You know, a geometrical figure is called as tetrahedron. Okay. Let ABC be a triangle and D be a point which is not in the plane ABC. Then ABCD is called a tetrahedron. The line joining DABC with the centroid of triangle ABC, triangle BCD, triangle CDA, triangle DAB respectively are concurrent. And the point of concurrence is called centroid of tetrahedron. This is the tetrahedron. Okay. That is a three-dimensional object It is a three-dimensional object where it has four faces and all faces are triangle. Okay. Centroid of a tetrahedron divides line segment joining vertex to centroid of opposite face in the ratio 3 is to 1. Okay. So here you see the centroid of a tetrahedron divide the line segment joining the vertex to centroid of opposite face in the ratio 3:1. If ABCD are the position vector of the vertices of a tetrahedron, then the position vector of its centroid is A plus B plus C plus D by 4. The unit vector bisecting the angle between the vectors AB are A plus B by A plus B magnitude. Okay. So here this is A vector, this is B vector, and this is A, this is B, this is A vector, this is B vector. Now angle between the vector A and B vector is A plus B by A plus B magnitude. Here this vector is T time A plus B. Okay. The internal bisector of triangle are concurrent. The point of concurrence is called incenter. The internal bisector of a triangle are concurrent and the point of concurrence is called incenter. The incenter of triangle ABC is AOA plus BOB plus COC by A plus B plus C. Okay, in vector algebra it is the incenter formula of triangle ABC, where A equal to BC, B equal to CA, C equal to AB. Now MCQ. The ratio in which the line segment joining x1 I cap plus y1 j cap plus z1 k cap and x2 I cap plus y2 j cap plus z2 k cap is divided by x I cap plus y j cap plus z k cap is x1 minus x is to x minus x2, y1 minus y is to y2 minus y, x1 is to x2, z minus z1 is to z minus z2. Okay. So first option is the right option. The ratio in which the line segment joining x1 y1 z1 and x2 y2 z2 is divided by the line xyz is x1 minus x is to x minus x2. Okay. Question number 2. The center of the triangle divide each median in the ratio 1:2, 3:1, 2:1, 1:3. Third option 2:1. The centroid of a tetrahedron whose vertices are A, B, C and D is, what is the centroid of tetrahedron? It is A plus B plus C plus D by 4. Centroid of triangle is A plus B plus C by 3. The internal bisector of angle between two vectors A and B is A plus B by A plus B magnitude. So, internal bisector of angle of two vectors A and B is T time A plus B, T time A cap plus B cap. Okay. Now exercise 4.2 short answer questions. The point O, A, B, X and Y are such that OA equal to A, OB equal to B, OX equal to 3A, OY equal to 3B. Find BX and AY in terms of A and B. Further, if the point P divides AY in the ratio 1:3, then express BP in the terms of A and B. Now solution. Bx equal to Ox minus Ob, that equal to 3A minus B. So Ay equal to Oy minus Oa, that equal to 3B minus A. So P divides Ay in the ratio 1:3, which equal to, that implies OP equal to Oy plus 3 Oa by 1 plus 3. That implies OP equal to 3B plus 3A by 1 plus 3. That is 3 by 4 into A plus B. So BP equal to OP minus OB. So 3 by 4 into A plus B minus B. So 3 by 4 A minus 1 by 4 B. So it is 1 by 4 3A minus B. So the point E divides the segment PQ internally in the ratio 1:2 and R is any point not on the line PQ if F is a point on QR such that QF is to FR equal to 2:1, then so that EF is parallel to PR. Now solution, let OP equal to A, OQ equal to B, OR equal to C. E divides PQ in the ratio 1:2. OE equal to 2A plus B by 2 plus 1, that is 2A plus B by 3. F divide QR in the ratio 2:1. OF is B plus 2C by 1 plus 2, which is B plus 2C by 3. EF is OF minus OE, which is equal to B plus 2C by 3 minus 2A plus B by 3. So 2 by 3 into C minus A by simplification, it is 2 by 3 PR. So EF is parallel to PR because EF is scalar multiplication of PR. So EF is parallel to PR. If AB are parallel, A equal to TB where T is scalar, we know that. Okay. Now question number 3. If PQR are the midpoint of the side AB, BC, CA of triangle ABC and D is any point, then express DA plus DB plus DC in terms of DP, DQ, DR. Then find alpha such that PA plus QB plus RC equal to alpha. Solution. PQR are the midpoint of AB, BC, CA. So DP equal to DA plus DB by 2. DQ equal to DB plus DC by 2. DR equal to DC plus DA by 2. So 2DP equal to DA plus DB. 2DQ equal to DB plus DC. 2DR equal to DC plus DA. So 2DP plus 2DQ plus 2DR equal to 2DA plus 2DB plus 2DC. So DP plus DQ plus DR is DA plus DB plus DC. So since PQR are the midpoint of AB, BC, CA, that implies PA equal to half BA, QB equal to half CB, RC equal to half AC. So alpha equal to PA plus QB plus RC, which equal to half BA plus half CB plus half AC. So alpha equal to half BA plus CB plus AC. Alpha equal to half BA plus AC plus CB. Alpha vector equal to half minus AB plus AB. So half 0 vector equal to 0 vector. ABCD is a parallelogram if L and M are middle points of BC and CD respectively, then find L and M in terms of AB and AD. Lambda if AM equal to lambda AD minus LM. Solution. Here ABCD is the parallelogram. L is the midpoint of BC. BL equal to LC equal to half BC. M is the midpoint of CD. CM equal to DM equal to half CD. ABCD is a parallelogram, that implies AB equal to DC, BC equal to AD. So ABCD is a parallelogram. So DC, M is the midpoint of DC, L is the midpoint of BC. Okay. Now you see AL equal to AB plus BL. So it is AB plus BL. BL is half BC. So it is half AB plus half BC, which is AB plus half BC is same as half AD. So plus equal to AB plus half AD. So AM equal to AD plus DM, which is AD plus half AB. Now lambda AD is AM plus LM equal to AM plus AM minus AL. So 2AM minus AL. So 2 into AD plus half AB minus AB plus half AD. By putting this value, it is 3 by 2 AD. So that is lambda AD is 3 by 2 AD. So lambda equal to 3 by 2. Okay. Now question number 5. ABCDE is a pentagon. If the sum of the vectors AB, AE, BC, DC, ED and AC is lambda AC, then find the value of lambda. Solution. ABCDE is a pentagon. AB plus AE plus BC plus DC plus ED plus AC is lambda AC. So AB plus BC plus AE plus ED plus DC plus AC is lambda AC. So AC plus AC plus AC is lambda AC. So 3AC is lambda AC. So lambda is 3. Okay. Now question number 6. ABCDEF is a regular hexagon and O is its center. Then prove that AB plus AC plus AD plus AE plus AF equal to 3AD equal to 6 times AO. Solution. Here it is the hexagon. Now in the hexagon ABCDEF, the center O bisect AD, BE, CF. AB plus AC plus AD plus AE plus AF equal to AB plus AE plus AD plus AC plus AF. So here A equal to BD, AF equal to CD. This is FB plus BD plus AD plus SC plus CD. So AD plus AD plus AD. So it is 3 times AD equal to 6 times AO. Okay. So this is all about in this part of addition of vector. In next part we will solve more problem and discuss more theory regarding the addition of vectors. So एमती more and more problem practice करो. So till then have a nice day. Bye bye students. Thank you all.